I don't think so. All right, good morning. Today is the 23rd of January, 2020. This is Math 1. We're talking about piecewise functions. We're missing Gordon. And Jordan. So Gordon and Jordan, you can... And who else? And Jackson. Okay. All right, give me the learning goal. Let's go with Greenlee.
I can graph various types of functions.
Cool, and give me the why, Maddie.
Graphs are all around me in the world. I want to be able to understand and create them.
All right. The U.S. has what's called a tiered tax system. I'm going to try to explain how it works and then relate it to what we're about to do. Depending on how much money you earn, you pay different percentages, but not on the total amount. It's kind of a stepped system. So let's pretend like, let's say that I make $170,000. According to this, and I can do a little bit of rounding, from 0 to 20,000, I'm going to be paying 10%. From 20 to, I'm going to round this up to 80,000. I'm going to pay 12%. So 0 to 20. So on my first, I make $20,000. I pay 10%. So what's my tax right there?
12.
10%.
$200. Wait, no, $2,000.
$2,000. Then from 20 to 80, that's another $60,000 that I made. And I paid 12%. Get out calculators. I want 12% of 60,000.
Wait, so it's 60,000.
So 60,000 times 12%.
Oh, 7,200.
7,200. Now, I just went over 80,000, or I'm going to say this one goes from 80,000 to 100 and, how much money did I say I made? 70? 170,000?
Yeah.
Okay, well, let's take this to 160. So how many thousands of dollars did I just earn in there? 80,000 at 22%.
9,600.
Is that right?
Yeah.
It's like 22% of it.
22% of 8,000.
17,000.
Oh.
And now I am my last getting up to my 170,000. So I've got 160 to 170. So $10,000 at 24%. $10,000 at 24%.
$2,400.
$8,000.
Wouldn't it be 100,000?
All right. So all of this totals up to $170,000. I make $170,000. Let's say that. The first $20,000 I pay 10% tax. From $20,000 to $80,000, that's $60,000. I pay 12% tax. From 80,000 up to 160,000, I pay 22% tax. And then from 160,000 to 170, which is that last $10,000, I pay 24% tax. And this is how the taxes work in the U.S. The more you make, as you slowly jump up higher and higher, you pay higher and higher taxes on those other amounts. Am I paying 24% on everything? No. Only on that little top piece. Here, we see, 34%. That seems like a lot of tax. You're only paying that on the chunk of your income over $600,000. If you're making $600,000, even if you're paying 37% tax, you're still walking around with, do 600,000 times do it times 66, 0.66. I'm finding the opposite of it to see how much I keep. So 0.66 times 600,000. 396. So you're still keeping 300, almost $400,000. It's still a lot of tax. I'm not arguing that. Okay, this is what's called a step function. That I'm walking around and suddenly what happens to, does my tax rate slowly go up like this, like a linear function like this? No. What it's doing is this. I'm paying this much tax, and then what happens? Oh, it jumps up. I'm paying this, and then what happens? It jumps up. And it jumps up. That's what we're looking at mathematically today. It's called a piecewise function, also called a step function, depending on what it looks like. So, on your paper, fold it to make 4 boxes. And you are going to need notes today. We are going to graph this.
Is that going in notes or on the graph paper?
This is going into the notes. This is a piecewise function. What it really is 2 lines. I'm going to be on one line, and then suddenly I'm going to jump and start graphing a different line. I'm going to show you what this equation really looks like. Really, this is y equals 2x minus 1, and y equals 3x plus 1. For x is less than or equal to 1, for x is greater than 1. It's 2 lines. This shouldn't be new. The idea between open and closed, closed and open, closed and open. On your graph paper, get the coordinate system ready to go. You are going to graph this piecewise function. Do not start graphing it yet, just get a coordinate system ready to go. You ready to graph a line?
Yep.
So let's start with this guy right here. First off, everything that's transitioning, it changes. So I'm walking along, and as soon as I get to 1, the graph is going to suddenly change. So I'm over here at -3, -2, -1, 0, 1. It's about to change. So right here is this transition. Very lightly, hopefully using a ruler, you guys got rulers, draw in a line right there. Very lightly so you know it's not part of the graph, it's just this line. It's the transition. And let's start graphing this. Miranda, where does Liam want to start his life for this one? Where? -3? No. This is the equation I'm about to graph. -1. He's going to start at -1. And then how is he going to move? So we're graphing this line right here. He's going to go up 2 and over 1, up 2 over 1, up 2. Now, don't draw the line. And do this very lightly with light points. Ready? He goes up 2 over 1. Up 2 over 1. Up 2 over 1. Let's bring it down. Down 2 over 1. Down 2 over 1. Just very, very lightly with those points because we're going to erase some of them in a second. But notice, this graph, right? He started over here. He's at like -2, -1, 0, 1. And what happens at 1? He stops. This stops at 1. So these points over there, they're not part of the graph. What we have is this. And now you can draw on the line. So you're connecting these little dots that turn into a line, but not on the right side of that line of the vertical, because that doesn't exist. Now Presley, what do you think? Right here at the line, should this be an open circle or a closed circle?
Should be close
Why do you think it's closed?
because it's a greater than or less than sign.
It's a greater than or equal to sign. Because of this guy right there, it's a closed circle. Which means that point is actually on that line. Maddie, we're going to graph the second one right here. Where does Liam want to start his life?
1.
Good. Little point, because we might have to erase it. How does he want to move?
Let's see, go up 3 over 1.
What points do I even want to keep? The left points or the right points?
For the left.
I want to keep these points over here.
Yeah.
No, I want to keep the points over here. I want to keep the points that are greater than the 1. I want to keep these points. This one I can erase. All right. Open or closed right here, sir. Open or
It
closed.
would be open
How do you know?
because it's not equal to.
It's just a greater than. There it is. Open circle. That is a piecewise function. You could just totally graph both of the lines and then erase half of it and erase half of it and make it work that way. I do it with little points so I don't have to erase as much. Okay. Open circle right there. Make it really like open. Make it a good open circle. Good. Let's do another one. The next one, just do it on the next coordinate system. Next square. Give this one a shot on your own. You just have two equations. What is the first equation, Fisher? Y equals
Y to X
minus 1, but you only want it over there when it's greater than 2. And then Chris, what's the second equation?
Y equals negative X
Plus 1, but I only want that over on this half of it. So you make sure it doesn't go across the line. So create a coordinate system. Drawing that vertical line around 2. So which one are you going to graph first? So start at -1. Up 1 over. Look. Up 1. Up 1. And down. What points do you want to keep? Yeah, that's what I want. So those points are on, and that's your line. So you start getting -1. Good, if you got it, now connect those. Make that a line. Use your ruler, Chris. That's the tool for the job. So you got that vertical. So our first line, let's start at -1. Put a point, go up 1 over 1. Not too dark. Put a point. 1 over 1. Put a point. Good. Keep doing it. Stop right there. Which points do we want? You know what? You started at -2. You want to start at -1. So erase what you got so far so it doesn't get confusing.
Why is the, like, so greater than equal to on the left and just greater than on the right?
Because the graph, this graph, he doesn't even start existing until 2. So his chunks, this graph doesn't even come into existence until I get over here, boom, that's when he finally pops into play. This guy, he exists when I'm less than 2. This graph only exists less than 2. This graph only exists greater than 2. So you start at -1, up 1, up 1. There we go. So that's the piece of what you want right there. This should be good. That's good. That's good. What's going on with yours? Are you using a... Yours looks good. That actually connect the dots. Using pen don't get out of pencil. Please get out. Okay. Yeah, this is my class is more pencil. I have pencils over by my front door every day, and then there. You know, what is it? So you graph these things. So let's just remember the graph. Got it. Okay, so this line's clear. Except what part do I want of it? I want the part that's greater than 2 or everything over. Get the wrong side. This is where we just erase this. The other one, which is right here, you got it. This side. Good. Where are you putting? You putting a circle there? All it's going is right here. All right. I need Fisher come up and graph the top line for me, and let's have Gavin the bottom line. And since it's dry erase, you can graph the entire line and then just erase it if you want to. It's a piece.
So am I doing the top one?
You're doing top. Cool. Nice, open or closed. Good. There it is. So this equation doesn't even come into existence until x equals 2, and then it pops up. And this one, he exists, but then as he comes down, he stops at 2. Questions about this? Any comments or concerns? I realize this is the more difficult thing that we've done lately. Next one. On the next coordinate system, just graph y equals 3. That's it. Graph y equals 3. Good, use your ruler. I don't want to use my ruler. Is it? Yep. Come on, JJ, hey. It's a light one. So go up to y equals 3. And draw a horizontal line. You fix that? Looks good. Y equals 3. I go up to y equals 3. 1, 2, 3. I put a line there and I draw a point there. Boom. Y equals 3. Now. Yes, you ready, Gavin?
It's on the small.
Okay, no, not that. This is it, man.
Wow.
What?
There are 4 lines.
Why would you? We're at
It's horrifying.
This is a step function. What it's really saying is, hey, y equals 1, y equals 2, y equals 3, y equals 4. But this little chunk of y equals 1, I only want it from 0 to 1. What would that look like if I graphed it? It would look like this. 0 to 1. Can you do the step that goes here? Can't see if you can do it. Give it a shot. Do something with it. I graphed the first little step for you, y equals 1 from 0 to 1. You're going to do y equals 2 from 1 to 2. Chris says he's getting it. So 1 to 2 with a closed at 1 and at 2. So this is the function. So you got to the second one is y equals 2. Where's the graph of y equals 2? But I only want the piece between 1 and 2. You got it. Micah, you're right. Right? That's y equals 2. Oh, this is y equals 2. But I only want the chunk. This is y equals 3. But I only want the chunk between 2 and 3. So there you go. Now you do the next piece. I want y equals 3. But only in that little chunk. Connect the dots. There's a little line there, a little line, a little line, a little line. Okay, you did this on the same graph, okay. JJ, hey, hey. So JJ, see this y equals 2. Here's the line y equals 2. Y equals 2. But I only want a little chunk of it. What little chunk do I want? The piece between 1 and 2. I only want that piece. And at 1, what kind of circle is it? Closed. And at 2, I'm going to graph y equals 3. Here's the graph of y equals 3. But I don't want the whole graph. I only want a little chunk of it. Fisher, come up here and show me the little chunk of it. Did I already have you come up today?
Yes.
Can I go up there?
Yes. Erase it, and so I just have my little chunk.
Sorry, use this one
Whatever you want, man.
finger. Okay.
It goes from 2 to 3.
Oh,
Ah,
I didn't
too
erase
much.
far enough.
Good. Open or close it. Closing. Opening. Good. I'm going to do the next piece. Y equals 4. Y equals 4. But I don't want all of that. I only want a little piece of it. Bradley, come up. And erase it except for the part that I want. Bradley, use that finger. Nice. Now open and close it. Nice. This is a step function. It's a piecewise function, but it's a specific step function because you're like, oh, look, it looks like little steps. Who has a 2-story house? Yeah. Okay. You know what steps look like. You climb them to go to your room. Yes, I understand. Now, this next slide just looks like a mess because I don't know what the heck happened to it, but yep. I don't even know. I do not know. It's crazy, okay. And we're going to call it, there's another step function. We're going to call it good. Homework. Go back into Google Classroom. Check it out. So, there's a file called EduElastic Key. Do a problem in EduElastic, go check it with the key. Do a problem, check it, do a problem, check it. It's trying to give you better feedback faster with the key. I'll be watching you. When it says to put an open circle, it's going to look really weird. It's going to be this big, crazy big open circle that you put on it. Don't try to shrink it down, because if you shrink it down, it's going to shrink down to a point, and then it's going to mark you wrong. So when you drop the circle on it, hit the circle and just leave it as this big, silly looking circle. Cool? A lot of this is just learning how EduElastic works and what I want from you. You can start the homework.